Hey all. So sorry I can't be there today, but I'm hoping that this is a good enough substitute. All right, so we only got through a little bit of our vocab from the first day. So we are going to do just a little bit more today and then how we can apply equations to that. All right, so let's go. So just quick recap. 2B got through this, but 3B did not. So let's look. We have parallel lines. Parallel lines, you should remember, and they look like this, right? They are the same distance apart. They're never going to intersect. Okay, so same distance apart, never going to intersect. However, like planes, right? They're never going to intersect either, hopefully up in the air, correct? But they're not always flying like this. They sometimes fly like this, right? So if you also have lines that never intersect, but they're not the same distance apart everywhere, then those guys are called skew lines. Skew lines. So skew lines is right here, and we have our parallel lines here. Notice these little arrows right here for parallel? That shows that they're parallel. And we have our parallel symbol, so we have line AB is parallel to line CD. Perpendicular lines, they're those ones that make the right angles. We have 4 right angles. So 1, 2, 3, 4, but all we need is one of those little squares in there to show that they're perpendicular. And this upside down T is your perpendicular symbol. So we have line AB is perpendicular to line segment CD. And we have 4 right angles. The last one is perpendicular bisector. A perpendicular bisector is like combining perpendicular, so 4 right angles, and bisect. And remember, bisect means to divide something into 2 congruent parts. So a perpendicular bisector, line AB is your perpendicular bisector because it divides CD into 2 congruent parts. These are my little things that show, these are called hash marks. They show that the 2 segments are equal, they're congruent. So CM is congruent to MD, so that's what it says here underneath my picture. Can I move my picture? There we go, okay. And it also says that AB is perpendicular to CD. So I have my 4 right angles here. All right, next one. So here's where we didn't get to in either class. So we have adjacent angles. So adjacent, if we were in class, I'd be standing next to the person who probably doesn't want me to stand next to him, and I would be saying, I'm adjacent to this person, right? So like, I'm adjacent to my coffee mug. I'm right next to it. That's what adjacent means, smack dab next to. So adjacent angles would be like angle BAC is adjacent. So BAC is adjacent to angle CAD. What does that mean? Does that mean anything special? No. It just means that they're next to each other. So they are angles that share a common ray. So I have ray AC, and they share the exact same vertex. So A is their common vertex. So that's adjacent. And then if you were printed your vocabulary notes from today and had them all nice and printed off and ready for you, you could be filling in those definitions. If I were you too, I might, because I'm always going to give you note sheets, I might take those notes, print them off if you have a printer, and put them in a binder, small binder. Or what you could do if you're doing everything digitally on like a Google Doc, because that's how I shared it. If you're typing this in, you can make a folder that says like geometry notes in your drive, so you could always put them in there. All right, how about linear pair? So a linear pair are adjacent angles, so ones that are next to each other. And they're formed by 2 intersecting lines. So, for example, angle 1 and angle 2 are a linear pair. So I want you to think about what that actually means real quick. So angle 1 and angle 2 are a linear pair. So 1 and 2 come together. Linear means like line, right? And pair is 2. So it's a pair of angles that form a line. So a linear pair of angles that form a line. That's it. So it's adjacent angles formed by two intersecting lines. So our linear pair. So now think about that logically. If you have a linear pair, what do they have to add up to degree-wise, measurement-wise? Think on that. All right, next one. Supplementary angles. Supplementary angles. If you remember from back in the day, supplementary means that they're going to add up to 180 degrees. So angle CAB, so angle CAB, sorry for my gross handwriting, and angle FEG or GEF, or angle E here, have to add up to 180 degrees. So is 98 plus 82 180 degrees? Yes, yes it is. So FEG, oh God, this is gross, equals 180 degrees. So determine whether a linear pair is supplementary. Why or why not? Tell me what it is. Yes, of course, right? Of course they're supplementary because a linear pair forms a line and a line is 180 degrees. 180, right? So if there are two angles that form a line, they have to be supplementary. Complementary, on the other hand, have to add up to 90 degrees. So they add up to a right angle. So if you were to have an equation here, you would want to say that, I'm just going to shorten it, angle A plus angle E are going to be equal to 90 degrees. How do we feel about that? So complementary angles form what type of angle when they are adjacent? And you would say that they form a 90-degree angle, which is a right angle. All right, so now I put together a little video for you to watch. This is what I would do if we were in class to show you a quick and easy trick to remember supplementary and complementary. Are you ready? I don't think you're ready for this jelly. Okay, quick way to remember supplementary and complementary. Is S in supplementary? Check it out. I can connect these guys right here, and then I put a 1 here, and I put a 0 here. 180 degrees. Crazy business. Complementary, they add up to 90. Oh my gosh, check that out. I can make that C and 9, and it is 90 degrees. So supplementary, 180, complementary, 90. Look at that. So simple little trick, right? All right, so what else do we have? We have vertical angles. These are huge in geometry. Huge, huge, huge. So you should know supplementary, you should know complementary. If you don't, make sure those are in your brain. Vertical, though, this might be new to you. Vertical are the ones that form V's across from each other, right? So vertical V, these guys are congruent. They are equal to each other. So your V's that are across from each other are equal. So I want you to think about that logically, right? So like if I have my arms like this and I'm moving my arms in and out, do you see how the angles that are across from each other are getting bigger at the same time and smaller at the same time? And my ones on the left and the right are doing the exact same thing. They're always going to be congruent. So I'm going to tell you what I call these in class. You're either going to think I'm a weirdo, which you probably already do, or you're going to be like, this is a great way to remember it. So I call these little arcs, they're called arcs, really. I call them butt cheeks. So like these are double butt cheeks and these are single butt cheeks. So when you have them, we mark it over here as this would be congruent to this one because they're opposite of each other. And then this is a single So it would be 82 and 82. And then look at this. 98 plus 82 gives me what? 180. Why? Because they're a linear pair, and linear pairs are supplementary. All that vocab. So these guys are always equal. And why do I call them butt cheeks? Here's why. Because when you have bisectors, like our next word, angle bisector, bisectors make butt cheeks. BB. Bisectors make butt cheeks. So if I have my angle bisector right here, right? An angle bisector is a line or a ray that divides an angle into two equal angles. It bisects it, divides it into two equal parts. So this ray right here, ray AF, remember we can't name it ray FA, have to name the end point first. Ray AF is your angle bisector, and it divides angle CAE into two equal angles. So as soon as I know that something's a bisector, I make butt cheeks. So this is 60 and 60. If I didn't know that that was 60 and 60, and I just knew that the whole angle CAE was 120, and I knew that ray AF was a bisector, then I know I put butt cheeks in and make them 60 each because they have to be equal. How do we feel about that? Okay. Now you have all of your initial vocab down. You have lines, you have rays, you have line segments, you have midpoints, you have bisect, you have angle, you have supplementary, you have complementary, you have perpendicular bisector, perpendicular, parallel, skew, coplanar, collinear, plane, point, vertical, angle bisectors, adjacent angles, and linear pair. Supplementary, complementary, did I say those? Now that we have all those, now how do we apply algebra to that? Here's how. All right, let's take a look at this first example. And this example is on your note sheet, so you can just have it printed out right there for you, or write it on a piece of paper. So we need to determine the measure of angle YXW. So if this were me, I'd immediately go to YXW, and I'd put a question mark here, because I want to know what is that measure. Because you're going to start getting confused. You're going to be like, am I finding X? And those people who make the quarterly are super tricky. And they're like, I'm going to put X as answer A. So you automatically pick that. But we want to know, what's that measure? So before we do that, we need to be like, what is the relationship? Here's what I'm thinking, my metacognition. What is the relationship between these two expressions that we have here? How does 7x minus 5 relate to 3x minus 25? Are they equal? Is XW a bisector? Do we know that? Because you can never assume. You know what happens when you assume. So what kind of relationship do they have? Look at it. Look at it. 3, 2, 1. If I know that this one is 90, so that means that YX and VZ are perpendicular, then I also know that this is perpendicular, forms that right angle, which means that those two have to add up to 90 degrees. So I would put 7x minus 5 equals, or 7x minus 5 plus 3x minus 25, 7x minus 5 plus 3x minus 25 equals 90 degrees. Definitely not 180 because it's not a line. I combine all of my fabulous like terms. So I have 10x minus 30 equals 90. I add my 30 in, and I get 10x equals 120. I divide by 10, and I get that x is equal to 12. Done. No, letter A, for if it's a multiple choice, is going to say 12. And guess who would be wrong? You. Because you didn't complete the whole entire thing. I want the measure of YXW. And YXW is 7x minus 5. But I need to substitute the 12 in. So 7 times 12 minus 5. So 7 times 12 minus 5. What does that give me? So 7 times 12 is 84. Minus 5 gives me 79 degrees. Which makes sense, right? Because 3 times 12 is 36. Minus 25 would give me 11. And 11 plus 79 equals 90. We're rocking and rolling. All right. I want you to look at the next one now. Here. All right. So let's get down to the last couple examples on this note sheet, right? So if we're looking at these angles, first thing we need to do, determine the measure of angle QVR. So let's figure out, where is QVR? So QVR is this angle. We need to figure out this measure, not the X value. What is the measure of it? So before we do that, we need to figure out what X is. And in order to figure out what X is, we need to create an equation. So equations for angles right now that you know, they're either adding up to 90, they're adding up to 180, or they're equal to each other. Those are your three choices. So looking at this one, I see that there are vertical angles. Do you see those V's that they create? V for vertical. So that means I'm going to have an equal sign in between. Equal sign in between those guys. So I set up my equation. X squared plus 14x plus 5 equals x squared plus 15x plus 1. So how do I solve this? I have x squareds on either side. Some of you may freak out and be like, oh, it's factoring. Not factoring right now because they both cancel each other out. So then I have my 14x on the one side, my 15x. So I'm going to take my 14x and move it over, and take my plus 1 and move it over to the other side. I get 4 equals x. Perfect. Guess what choice A is? On multiple choice, 4. We don't want that. We want the measure of QVR. So what are we going to do with that 4? We're going to take that 4. We're going to substitute it in. So I'm substituting it into that x squared plus 15x plus 1. Technically, it doesn't matter, right? Because they're equal. But we do that. So measure of QVR is x squared plus 15x plus 1. I substitute my 4 in. 16 plus 60 plus 1. Add them all up. And I get 77 degrees. So the measure of QVR equals 77 degrees. All right, let's try this next one. So here I have two angles. So I look, are they complementary? Add up to 90. Are they supplementary? Add up to 180. Or are they vertical? They're equal to each other. I need to determine the measure of QVR. QVR is my angle I'm trying to find. Oops. And I know that these two angles right here are a linear pair, which means they have to add up to 180 degrees. So I'm going to say that 7x plus 10 plus 4x plus 5 equals 180. Find my like terms, which would be 7x and 4x and 10 and 5. Combine them. 11x plus 15 equals 180. Subtract my 15. I get 11x equals 165. Now I have to divide by 11. And I get x equals 15. Choice A, 15. Hands down, every time. Choice A, 15. Don't want that. I want to know what is the measure of QVR. So I'm going to take that 15. What am I going to do with it? Oh, I'm going to substitute it. So I'm going to do 4 times 15 is 60. Plus 5 gives me that 65 degrees. All right, let's check out the next one. GE, ray GE, is the angle bisector of DGF. So here's GE, and it's the angle bisector of angle DGF. Bisector, butt cheeks. So I'm going to put those butt cheeks in there. Bloop, bloop. And that means that those two are congruent to each other. It's a bisector. They are equal. We need to figure out what the measure of DGF is. DGF. So DGF is the big old angle. So I want to know, what is this angle right here? Why does it keep doing that to me? All right. I want to know, what is that angle? So I know that those two are equal to each other. So that could be the start. So I set them equal. I have that 2x plus 14 equals 68 minus x. I now have to solve. I can add my x over and subtract my 14. And I get 3x equals 54. Divide by 3, and I get x equals 18. Am I done? Nope. So think about this logically here. I need the whole big angle. But I don't have an expression for the whole big angle. I have an expression for the smaller angles. And I know one of those smaller angles plus the other smaller angle gets me the big guy. I also know that one of those angles times 2, because they're the same thing, gets me the big guy. So I could pick any one of these. So I picked 2x plus 14. It's 50. So 2 times 18 plus 14 is 50. So if this one right here is 50 degrees, and they are the same thing, 50 degrees, that means the whole big one has to be 100 degrees. So let's see, is that what I got? Yep. So 50 times 2 is 100, which is the measure of angle DGF. If you were a teacher and you were creating a question bank, or an answer bank, things you would pick, 3 of them. Go. What would you put in there? I would put 18. I would put 50. And I would put 100. And then maybe like a weird one. Like if maybe you added them up and set them equal to 180 or something like that. What would X be? All right. Last one. I know this says challenge, but technically it's really not a challenge. What is the value of X? So we're finally just finding X. Yay! So what is this value of X here? We want to know. What is X? So how are we going to do that? All right. I need to somehow relate the numbers I have and what I know. I know that this here is a 90-degree angle. So it has that little right angle, but you might not like necessarily think that in your head. I like to draw all over my pictures. I also can tell that this line right here and this line right here create vertical angles across from each other. And we know that vertical angles are equal to each other. They are equal. So this together, 90 plus 32, is going to be equal to x squared minus 22. So that's the equation that we are setting up. We combine our 32 plus 90. We get 122. We add our 22 over, and we get that it's 144. So now I have x squared equals 144. What is the inverse of squaring? So how do we get rid of that square? Or you're saying what times itself gets me 144? So we take the square root of both sides. Square root of both sides. So this guy goes away, this square right here, those all go away, and I'm left with just x. And the square root of 144 is 12, right? We know it's 12. But I hope there are some of you out there, so this is 12, but I hope there are some of you out there that said, you know what? Another number times itself also gets me 144. So think about that for a hot second. What other number times itself gets you 144? I hope maybe one or two of you came up with this because it's a little bit of a difficult concept at first, but then after you see it once, you're like, oh, duh. Remember that a negative times a negative is also a positive. So a negative 12 times a negative 12 is also a positive 144. So when you take the square root of a number, it gives you a positive answer and a negative answer. And then I check in and I look, does a negative answer make sense? 12 squared is 144. And then minus 22 would get me 122. Negative 12 squared, so negative 12 times negative 12 is 144. Minus 22 gets me 122. Perfect. So both answers make sense. I now have two answers to that problem. All right. Hope y'all are good on this. Sorry, wasn't there today. I'll be there on Tuesday. Promise. Later.